Hello everybody, I'm Vedran Jukic, Chief Technology Officer of OneSource Solutions International from Boston and Research and Development ServerNet Lab in Trieste, Italy. Today, I will present the concept and the product of medical data governance, which collects, stores, and presents data from medical devices targeting clinical research, hospital information system, such as electronic medical record, diagnosis, education, and most importantly, the machine learning and finally artificial or augmented intelligence. Everything starts with the patient, which is, in most hospitals and critical care environments, associated to a location. Equipped with medical devices such as patient monitors, ventilators, anesthesia machines, syringe and IV pumps that are continuously producing vital clinical data from the patient, which is more than 6 million data samples per hour. However, despite being intrinsically continuous, this data is typically collected at discrete time intervals, whenever a care provider manually records the data on a paper or enters the data into electronic medical record. Thus, 99.9% of the vital data coming from the bedside devices is lost forever. Data from other medical devices such as thermometers, ambulatory measurement devices, DICOM, and lab equipment are taken when the patient is not in the bed or not associated to a location. As a result, the vast majority of metadata, my estimation over 90%, is not preserved. For example, who took the measurement, when the measurement was done, what was the condition of the measurement, all that contextual metadata that are crucial for artificial intelligence to be effective. In both cases, the EMR or paper chart is still legally and practically the destination and true source of data for other systems with one mostly unsolved crucial problem: the positive patient association. The EMR holds a very small percentage of the data coming from medical devices and with huge space for errors. As a result, caregivers are basing their opinion on only 0.1% of the data that the nurse records, which happens to be the instantaneous value at that time. It is not recording the best representation of the data for a given time interval, thus not telling the true patient story. Our goal was to create a robust middleware system that can capture, normalize, and time synchronize the data from bedside medical devices, spot and ambulatory devices, home devices, wearable devices, video, for example, and even eventually provide the most important 0.1% of the data to the EMR while still preserving 99.9% of the data. Medical device governance essentially takes the data in real time and consolidates it before the data can be served to other applications. Researchers, EMR, education, diagnosis, and up to artificial and augmented intelligence. MDG is designed to perform two simple tasks: timestamp and clinical set by association. Timestamp the data and save them in a raw and normalized format. This accomplishes our goal to preserve 99% of the data while also adding and distilling the most representative information to the EMR. Second is to create clinical sets by association, such as patient with a location, doctor with a location, nurse with a doctor, doctor with a drug, drug with a location, and many more. Those associated sets create an important metadata that must be and will be used as a context to the data that was collected from the medical devices. MDG is implemented through the use of bedside medical Internet of Things, or IoT or IOMT, and the edge computing devices. Those devices are usually located within 1 meter from the patient. The intelligent IoT device collects and preserves about 2 GB of data per hour per patient and then pushes it to the edge computers to store. Those edge computers heavily compress this data before they push it to the servers. Those servers can be located within the perimeter of the hospital, on-premise or off-premise, all encrypted and all compliant to legislation such as HIPAA, MDR, and any other safety and privacy protocols that must be observed. Essentially, the main goal of medical data governance is to preserve 99.9% of the medical data and 99.9% of the metadata for researchers and artificial intelligence, and then eventually to provide very small but meaningful data set for the MR. More importantly, MDG will provide caregivers with actionable informatics that includes a more comprehensive yet still simple look at their patient's health. MDG also provides hospital with access to previously inaccessible medical data and metadata, paving the way for novel analysis and opening the doors to all sorts of possibilities with artificial intelligence. There is a global goal to digitalize hospitals. The question becomes, when is one to do with all of the data? The modern EMR was not designed to handle this vast quantity of data. A solution like medical device governance is a keystone technology to make this a reality. It is also a keystone for a pan-European research platform where normalized, de-identified data can be securely shared in a real time to foster collaboration. I want to relate to each of you, me as an engineer and you as a doctors. When taking care of patients in an ICU, you rely upon the nurse to be your eyes and ears, as it is impossible to be at each patient bedside for 24/7. When the situation changes and the patient decompensates, this is when the nurse calls you for your management advice. This is a reactionary environment. MDG can transform this into a proactive environment by providing you real-time data information, and at the same time, complete data and metadata for research and artificial intelligence. Thank you.